Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Think back to the architectures we've built. You've got Aurora replicating data across regions, DynamoDB global tables handling active writes, EKS clusters running workloads, network layer connecting everything. All of this is distributed. All of this can fail. 2 a.m., you get paged. Users reporting errors. Revenue dropping. Every minute costs $50,000. Which region is failing? Which service? Is it Aurora lag? DynamoDB throttling? EKS pod crashes? Network issues? You have 10 minutes to figure it out before the incident escalates to executive leadership. Where do you even start? Today, you're learning how to build observability that actually helps during incidents. Not dashboards that look pretty in demos. Not logging that costs $15,000 per month and tells you nothing. Observability that gets you from something's broken to here's the fix in under 5 minutes. By the end of this lesson, you'll know how to design centralized logging that aggregates from multiple regions without drowning you in noise. How to implement distributed tracing with X-Ray to follow requests across regions and services. How to build cross-region dashboards and alerts that wake you up for the right reasons. And the observability anti-patterns that cost teams hours during incidents. Let's start with the problem nobody wants to talk about. You've built multi-region. Production is running in US East 1 and US West 2. Aurora, DynamoDB, EKS, the whole stack. Users start reporting 500 errors. Checkout is failing. You pull up CloudWatch in US East 1. Scroll through logs. Nothing obvious. Check US West 2 logs. Also nothing obvious. Check EKS pod logs. Hundreds of pods across 2 regions. Which one has the error? 10 minutes have passed. You still don't know which service is failing. Revenue loss. $500,000 and climbing. This is the multi-region observability problem. Your logs are scattered. Your metrics are per region. Your traces don't cross regional boundaries. You've built a distributed system, but you're trying to observe it with single region tools. Here's the reality. The median time to identify which service caused a multi-region outage is 45 minutes. Not resolve, just identify. For a hot-warm architecture handling $1 million per hour, 45 minutes is $750,000 in lost revenue. Centralized observability cuts that to 5 minutes. That's a $700,000 difference. Let's talk about how to build it. First, centralized logging. You need all logs in one place. Queryable in real time, without costing more than your compute infrastructure. CloudWatch logs is the starting point. Each region has CloudWatch logs, your EKS pods ship logs there, Aurora ships query logs there, application logs go there, but you've got separate log groups per region. Querying requires opening multiple CloudWatch consoles. Correlation is manual. CloudWatch logs insights gives you cross-region queries. You write one query, it runs across all regions, aggregates results. This is your first layer. Here's a real query pattern. User reports, checkout failing. You search for their user ID across all regions, all services, last 5 minutes. CloudWatch logs insights pulls matching log lines from US East 1 EKS, US West 2 EKS, Aurora in both regions, DynamoDB in both regions. Shows you the exact error. 2 minutes to root cause instead of 45. But CloudWatch logs gets expensive fast. 500 gigabytes per day ingestion costs $30 per day. That's $900 per month. 3 regions, 1,500 gigabytes per day total. $2,700 per month just for ingestion. Add retention and queries. You're at 4,000 monthly. Cost control strategy. Don't log everything. Log what matters. Application errors, database slow queries, authentication failures, API 400s and 500s. Don't log successful health checks. Don't log debug level noise. Don't log every single request. Sample. For long-term storage and analysis, ship logs to S3. CloudWatch logs to S3. Export costs 1 cent per gigabyte. 500 gigabytes per day equals $15 per month. S3 storage is 2 cents per gigabyte per month. 15 terabytes equals $300 monthly for storage. You've cut costs from $4,000 to $300 for long-term retention. Query S3 logs with Athena. Write SQL queries against log files. Costs $5 per terabyte scanned. For incident analysis, you're typically querying 1 day of logs, maybe 15 gigabytes. 7 cents per query. Cheap. Log structure matters. Use JSON. Include trace ID, user ID, region, service name, timestamp, log level, message in every log line. This lets you correlate across services. Example log line. Timestamp, level error, service checkout API, region, US East 1, trace ID ABC 123, user ID user 456, message, DynamoDB throttling exception on orders table. With that structure, you can query, show me all errors for trace ID ABC 123. You get the full request path across all services, all regions. Root cause in 30 seconds. Now let's talk about distributed tracing. Because logs only tell you what happened in individual services. Tracing shows you the flow. AWS X-Ray gives you distributed tracing across regions. Here's how it works. Every request gets a unique trace ID. When your front end makes an API call, it passes the trace ID in headers. The API service includes that trace ID in logs and sends trace data to X-Ray. API calls Aurora passes trace ID. Aurora query logs include trace ID. API calls another service in US West 2 passes trace ID across regions. X-Ray builds a service map showing the full request flow. Front end to API in US East 1, 20 milliseconds. API to Aurora in US East 1, 80 milliseconds. API to another service in US West 2, 150 milliseconds cross-region. That service to DynamoDB in US West 2, 30 milliseconds. Total request time, 280 milliseconds. You can see exactly where time was spent. You can see where failures occurred. Real production example. E-commerce checkout failing for some users. Trace ID shows. Front end calls checkout API, success. Checkout API calls inventory service, success. Inventory service calls DynamoDB in US West 2, timeout after 5 seconds. That's your failure. Without tracing, you check front-end logs. Nothing. Check checkout API logs. Nothing obvious. Eventually dig into inventory service logs. Maybe find DynamoDB timeouts if you knew to look there. 30 minutes of troubleshooting. With tracing, you pull up X-Ray service map, filter by error traces, see DynamoDB timeout immediately. 2 minutes to root cause. X-Ray costs per trace. 1 million traces per month costs $5. 10 million traces, $50. For most applications, this is negligible compared to the incident cost savings. But you need to instrument your code. AWS SDKs have X-Ray support built in. Python, Node, Java, Go. You add the X-Ray SDK, wrap your HTTP client, traces get sent automatically. For EKS, you run X-Ray daemon as a daemon set. Pods send traces to the daemon. Daemon forwards to X-Ray service. Cross-region tracing works automatically. Trace IDs propagate across regional boundaries. Your service in US East 1 calls a service in US West 2. The trace shows both regions in the same flow. This is critical for hot-warm architectures where requests might fail over mid-flight. Now, dashboards and alerting, because this is where most teams fail. Don't build per-region dashboards. You'll have US East 1 dashboard, US West 2 dashboard, EU West 1 dashboard. During an outage, you're flipping between 3 dashboards, trying to figure out which region is broken. Cognitive overload. Build unified dashboards. One dashboard showing all regions. Aurora replication lag. US East 1 to US West 2 showing 45 milliseconds. US East 1 to EU West 1 showing 120 milliseconds. All on one graph. When lag spikes, you see which region immediately. EKS pod health. Total pods across all regions. Pods running, pods failing. If US West 2 has 50 failed pods and other regions are green, that's your problem. Application error rate, requests per second, and error rate per region. When US East 1 error rate jumps to 30%, you know immediately. What not to show. Don't show individual pod CPU metrics. Not useful during incidents. Don't show every single metric. Focus on signals that indicate failures, error rates, latency 99 percentile, replication lag, failed requests. Alerting strategy, alert on impact, not symptoms. Don't alert on pod restart. Pods restart all the time. Alert on sustained high error rate across many pods. Don't alert on single slow query. Alert on overall database latency 99 percentile above threshold. Example alert. Aurora replication lag above 10 seconds for 5 minutes. That indicates a real problem, not a transient spike. The alert includes a runbook. Check Aurora CloudWatch metrics for CPU and I/O. Check network connectivity between regions. Check if there's a large transaction blocking replication. Here's the command to manually promote secondary if needed. Alerts without runbooks are noise. You get woken up, you don't know what to do, you spend 20 minutes Googling. Write runbooks first, then write alerts. Common observability mistakes that cost teams during incidents. Mistake 1, logging everything. Teams enable debug logging in production, ship everything to CloudWatch. 500 gigabytes per day becomes 2 terabytes per day. Costs explode from $900 to $3,600 monthly, and you still can't find relevant errors because they're buried in debug noise. Fix. Log at appropriate levels. Error and warn in production. Info for important transactions. Debug only during active troubleshooting. Mistake 2. Per-region dashboards with no unified view. During hot-warm failover, you need to see both regions simultaneously. Are requests actually moving to secondary? Is Aurora lag increasing? Per-region dashboards force you to context switch. Fix. Build unified dashboards showing all regions on the same graphs. Mistake 3. Alerts without actions. Alert fires, says DynamoDB throttling in US West 2. Okay, what do? Increase provisioned capacity? Switch to on-demand? Is this expected traffic or an attack? No runbook means 30 minutes figuring out next steps. Fix. Every alert includes runbook with specific remediation actions. Mistake 4. No sampling strategy. Teams try to trace every single request. 10,000 requests per second equals 10 million traces per hour. That's $50 per hour just for tracing. 1,200 daily, 36,000 monthly. Fix, sample, trace all errors, trace 1% of successful requests. You'll catch issues without the cost explosion. Before we wrap up, pause and answer these questions. Question 1. Your application generates 500 gigabytes of logs per day. You need to query last 7 days during incidents. Should you keep everything in CloudWatch logs or export to S3? Question 2. A user reports checkout failing. What's the fastest way to find the root cause across multiple regions and services? Question 3. You're getting paged for pod restarts in US East 1. Should this be an alert? Take a moment. Answers. Question 1. Export to S3 after 24 hours. Keep last day in CloudWatch logs for real-time queries during active incidents. Older logs in S3 with Athena queries. CloudWatch costs for 7 days of 500 gigabytes daily, over $2,000 monthly. S3 plus Athena, under $400 monthly. You save $1,600 monthly. Question 2. Distributed tracing with X-ray. Search for the user's trace ID. See the full request path across all regions and services. Identify exactly where the failure occurred. 2 minutes to root cause versus 30 minutes checking logs region by region. Question 3. No pods restart all the time. Deployments, node maintenance, resource limits, transient failures. Alerting on individual pod restarts creates noise. Alert on sustained high pod failure rate affecting user experience. Focus on impact, not symptoms. Let's recap what we covered. First, centralized logging with CloudWatch Logs Insights aggregates logs from all regions. Cost control requires sampling. Log what matters, skip noise. S3 export for long-term storage cuts costs by 80%. Second, distributed tracing with X-ray shows request flow across regions and services. Trace IDs propagate automatically. Service maps visualize the entire path. Critical for troubleshooting multi-region architectures. Third, unified dashboards show all regions on the same view. Alert on impact, not symptoms. Every alert needs a runbook with specific remediation steps. Fourth, common mistakes. Logging everything. Per region dashboards. Alerts without runbooks. No sampling. All cost time and money during incidents. Fifth, the goal is 5 minutes from alert to root cause. Centralized observability makes this possible. Without it, you're averaging 45 minutes. That's $700,000 difference for high-revenue applications. Remember episodes 3 through 6? You built the data layer, the compute layer, the network layer. Observability is how you see what's actually happening in production. When Aurora lag spikes in episode 3's architecture, you need metrics showing it. When DynamoDB conflicts from episode 6 happen, you need logs capturing them. When network issues from episode 5 cause timeouts, you need traces showing where. We'll revisit observability in episode 12 when we cover disaster recovery and failover procedures. You'll use these dashboards and alerts during an actual failover. And in episode 15, anti-patterns, we'll see what happens when teams skip observability. The blind failovers, the extended outages, the lessons learned the hard way. Next time, DNS and traffic management with Route 53 and Global Accelerator. You've got observability showing what's happening. But how do you actually route traffic between regions? How does Route 53 health checking work? What's Global Accelerator and when to use it versus plain DNS? You'll learn Route 53 health check configuration that detects failures in under 60 seconds. How failover routing policies actually work in practice. When to use weighted routing versus latency-based routing. Global Accelerator for sub-second failover with anycast IPs. And the DNS gotchas that caused outages. TTL caching, health check, false positives, the works. Because having 2 regions means nothing if you can't route traffic to the healthy one. DNS is your control plane for multi-region architectures? Get it wrong. And your hot warm becomes no warm during failures. See you in episode 8.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.